Okay. Okay. Welcome to the Excel for Statistics course. By the end of the course, I hope you will be able to perform basic business statistics analysis using Microsoft Excel. And through this course, you will also learn some of the benefits of using Microsoft Excel for daily needs, which will help you to be able to perform better at your job and your business. Let me share the PowerPoint for you first. Okay, so this is the last chapter, chapter 12, linear regression. Okay, so now we will learn about the linear regression. Okay, as you can see in here, linear regression is a type of data analysis that considers the linear relationship between a dependent variable and one or more independent variables. So we will learn about the simple regressions and multiple regressions. Simple linear regressions has only one x and one y variable. But for the multiple linear regressions, has one y and two or more x variables. Okay, so the difference between simple and multiple is the simple has only one x and one y variable, but for the multiple is one y and two or more x variables. Okay, so let's go into the Excel. Okay, wait. Let me open the Microsoft Excel for you. Oh, not this one. Sorry. Okay. Okay. So we have simple regression for the first regression, linear regression that we will learn for now. Okay. So we have this data set. There are employee, machine, and number sold. Okay, so in the simple regression, we want to see the relationship between the employee and the number sold, the number product sold, and then the second relationship that we want to see is the machine, the number of machine, and then the number of product sold. But for the first one, we will learn about the employee, the number of employee, the relationship between the number of employee and then the number of sold. Okay. So I hope you already type these data sets into your Microsoft Excel. But if you don't, just type it in your Microsoft Excel. You can pause the video, and after that, you can play this video again. Okay, so I hope you already finished your data set. So let's go to Data tab, choose the analysis, and choose regression. Okay, for the Y range, put the number product sold in here. And for the X range, for now, I want to see the employee, the number of employee, and then the number of products sold. So the range is from the employee until the 4. And then labels, confidence level, output range, put here. Okay, no problem at all. And then the residuals, check the residuals, and then click OK. So this is the results. Okay, so we have the output. So in this output, we can see the regression statistics. We have multiple R, R square, adjusted R square, standard error, and observation. So the number of multiple R is 0.7, around 0.7, and then the R square is 0.5, around it, and then adjusted R square is 0.5. The standard error is around 8.2, and then for the observations is 20. Okay. Okay, so for the R square in here, okay, for the regression statistics, the conclusion that we will take is the R square number. Okay, when the R square is okay, so when the R square number is more near to the 1, then the into the 1 is more good or more fit. Okay, so right now the number of R square is 0.53. So it's still far, not near the 1, but it's still far. So it is not, it still can be used, but it's not as good as like 0.9 or 0.8 and so on. Okay, so to see the fitness of this data is the more the number is near the 1 is more fit. Okay, and then the next one, the ANOVA analysis. Okay, so for the ANOVA analysis, we can see the regression, residual, and total. Okay, so for the TF number of regression is 1, the residual number, the TF from the residual is 18, the SS, the MS, F, and then the significance F. Okay, so the conclusions from the ANOVA analysis we can see in the significance F. Okay, the cutoff of the significance F number is 0.05. Okay, so right now our significance F is below the 0.05. Okay, the value is less than 0.05, so our data is okay. But if it's above 0.05, so it's not okay. And then for the for the next analysis, we have intercept and employee. There are coefficients, standard error, t-stat, p-value, lower, upper, lower, and upper. Okay, so the number that we can see in here is this one. Okay, so when the number is below, so the p-value number must be below the 0.005. So when the number of p-value is below 0.05, it's already good. But if the number of p-value is above the 0.05, so the conclusion is the data is not good. Okay, so this is the residual output. Okay, but the number that we are consider is the R square. the significance f, and then the p-value. So this is the first example of simple regression. Then this one is the new dataset. Okay, I hope you type the dataset first in your Microsoft Excel. You can pause the video, and after that you can play this video again. Okay, so I hope you already finished your dataset. Okay, so we have quantity, price, and cost. Okay, so right now I want to see the relationship between price and quantity, and cost and quantity. Okay, price to quantity and cost to quantity. Okay, so let's do the regression analysis. Okay, the input, the first one is cost. I'm sorry, the Y range is the quantity, and then the X range is the cost. Okay, all is good. I don't want to see the residual for now, and I click OK. And then, as you can see in here, okay, so the R square is near the 1, okay, the number, the 1 number, okay. So as you can see in here, because it's near 1, so we can see the data is fit. And then for the ANOVA analysis, okay, I think we must change the data first, but if it's below 0.05, it's all good. And then for the p-value, if it's below the 0.05, L is good. And now I want to see the relationship between price and quantity. Okay, so let us do one more again for this data set. Okay, but change the X into the price. Click OK. Wait, for the output range, I put it in here, F24. So this is the results. Okay, for the R square, it's far from 1, so it's not fit. Okay, for the significance F, it's more than 0.05, so it's not good. For the p-value, it's more than above 0.05, so it's not that good too. Okay, so the data set, the relationship between price and quantity, we can assume it's not fit and it's not good from the ANOVA analysis and then the p-value analysis. Okay, so I think we must try once again, because this one is from the employee. Let's just do the regression analysis for the relationship between the number of salt and the machine. Okay, for the output range, I will put it into F51 without residuals, and okay. Oh, sorry, there's a different input Y. Okay. Okay, the R square, with the relationship between the machine and the number solved, the R square is far from 1. The significance F is more than 0.05. and then the p-value is more than 0.052. So the relationship between machine and the number of machine and number of solved is not that good. And then we will learn how to do the multiple regression. Okay, so for the multiple regression, we have these data sets. So I hope you type the data set first, and after that, you can pause the video, and after that, you can play this video again. Okay, so I hope you already finished your data sets. So let's do the regression analysis. But for now, because it is multiple regression, so we have two x variable, two or more x variable. Okay, so for the y variable is number of solved, but for the x variable we put employee and machine. Okay, both of it. And then check the label, check the confidence, check the output range. The output range will be at F4. Okay. Okay. So this is the results. Okay. So from the output for the R square, it's 0.18. Yeah, so it's more likely near the 1. So it's still good. The significance, we still need to change the number, but for now, if it's below the 0.05, it's all good. And then for the p-value, okay, so for the machine is below 0.05. So it's all good for the machine, but for the intercept and employee, we still need to change the data, the number, okay? And then for the last example, so we have these data sets. You can type the data set first, and after you can pause the video. And after that, you can play this video again. So I hope you already finished your data sets. And let's try to do the multiple regression data analysis in the Microsoft Excel. Okay. So the Y range is the quantity. Okay. And then for the input X range is the price and the cost. Okay. For the F4, all good. Okay. So this is the results. Okay. So from these data sets, as you can see, the R square number is near 1. So it can be considered as good. And for our significance F, we still need to change the number, but now if it's below the 0.05, it's good. But if it's above 0.05, it's not good. And then for the p-value, okay, as you can see in here, so the intercept is below 0.05, so it's good for the intercept. And then for the price is above the 0.05, so it's not good. For the cost, we still need to change the number. Okay, so I think that's all for the simple regression and multiple regression. So remember, when you do the simple regression and multiple regression analysis, don't forget to see the R-squared number, the significance F number, and then the p-value number. Okay, so that's how to do the regression analysis in Microsoft Excel. And this is our last course material for Excel for statistics. So I hope you learn a lot in this course, because my concern is how to do these functions, this analysis in Microsoft Excel. Okay, I cannot give you more deep analysis or like that because yeah, my concern for now is how to do the function, how to do the analysis in the Microsoft Excel. So we already learned a lot actually from the introduction and then how to organizing the data and then Excel statistical functions and then the descriptive analysis and hypothesis testing, ANOVA, and the last one is linear regression. So I hope you learn a lot for this course, from this course, and I hope you are enjoying to learn the Excel, Microsoft Excel, because it's very useful for you in your job or in your study and or in your business. So I hope you're enjoying it much. And thank you for uh, joining my course and see you in another chance. Goodbye.